back at AP Review. This is 2010, Form B, BC free response number 2. The velocity vector of a particle moving in the plane has the components given by these two parametric equations. I already put dx dt in as my x1t in the calculator, and I put dy dt in as my y1t in the calculator. This is for t values between 0 and 1.5 inclusive. And at time t equals 0, the position of the particle is negative 2, 3, meaning one way to think about that is that x of 0 is negative 2 and y of 0 is 3. Part A, for the open interval from 0 to 1.5, find all values of t at which the line tangent to the path of the particle is vertical. Okay, so this requires us to know the big overarching concept in this is knowing what it means to have a vertical tangent line, right? So remember that the slope of the tangent line is dy dx, right? What we're asking for in a vertical tangent line is for the denominator of this thing to be 0, but more specifically, because in parametric that would be dy dt divided by dx dt, what we're looking for, right? So if we have a vertical tangent is going to mean that dx dt is 0, and this is important, dy dt is not, because 0 over 0 would be an indeterminate form. It would not be an undefined slope. 0 over 0 would be an issue that we'd have to do more math to resolve. So the important piece of information here is we're looking for values that are 0 for dx dt, but not 0 for dy dt, right? So I need to find the values for which this dx dt is 0, right? But dy dt is not 0. So I already have these in my calculator in parametric mode, but when I go to second calc, what I want you to notice is that in parametric mode, you can't second calc 0, which is frustrating, but it's a reality of the situation. So what I really want to do, right, is I want to put my dx dt in as a function and second calc 0. So again, the thing to note is that although you want to be in parametric mode in all likelihood, unfortunately, being in parametric mode right now is not helpful to you. So what I'm going to do is I'm going to go to mode, I'm going to go to function, right? And these are functions from a previous problem, and I'm going to put in exactly what my functions are, but instead of using t, I'm going to use x because I'm in function mode. So 14 cosine of x squared, sine of e to the x, right? And for my y2, I'm going to put in 1 plus 2 sine of x squared, right? Now I'm going to turn off my y2 for a second, right? So if I want the values where dx dt, so what I want you to notice is that in this problem right now, I put dx dt in as y1 and I put my dy dt in as y2 because in order to second calc intersect, so this is my y1 equals 0, and then, I'm sorry, second calc 0, then I can second calc 0. In order to do that, I need to be in function mode. So that's what I'm going to do. So I'm going to go ahead and graph this, right? And I'm going to graph this. And there's going to be multiple, there's going to be, like, as you can see, there's a ton of values that are zeros, right? But remember that I'm only looking in the window from 0 to 1.5. So you might want to go to your window and actually change your window to have your x's only go from 0 to 1.5. So I'm looking for values of 0. And actually, I won't need y2 to be dy dt in a second anyway. So you'll notice there's 2 zeros there because it's subtle, but this definitely dips below the axis and goes back up. So there's 2 zeros. So I'm going to do second calc 0. And my cursor right now is coming down, right? So I don't want to cross the axis, so I'm going to stay above it, hit enter, and then cross below it, enter, and then guess. So I'm going to get 2 t values. I'm going to get t as approximately 1.1447299, which I'm going to call a. So I'm going to quit out of this for a sec. I'm going to type the x, and I'm going to store that as alpha a, and I'll show you why in a minute. So, and then I'm going to go back to my graph, and I'm going to second calc 0 again. I'm going to find the other one. Start below the axis, I cross the axis, and then hit enter, and I'm going to get a second t value, which is going to be 1.2533141, and that's just like the other one should have a dot, 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 but I'm going to call that b. So I'm going to quit out, right, and I'm going to hit x, and I'm going to store that as alpha b. Okay, so here's the thing. I don't need to find where dy dt is equal to 0. I just need to check that at both of these values, dy dt is, that I need to check that at both of these t values, dy dt is not 0. So if I go back to my mode, and I go back to parametric, although parametric doesn't let you second calc 0, what it will let you do, right, is it'll let you trace the same way that we traced before, right? So, so if I hit trace, and then I type in alpha A, it'll give me that my x is 0, which is not surprising, and that my y, so if I wanted to find dy dt at that A value, it's approximately 2.932 or 3, which is not 0, right? That's all I care about. So this is a legitimate answer. And then the other one, if I do trace and I do alpha b and hit enter, I'm going to get that dy dt at t equals the thing I called b is a 3. In fact, it's not even approximate. It's just straight up a 3, right? And so once I get that, right, once I get that value, I know that neither of those are 0. So at both of those spots, I have a value. So my answer is 1.144, or 5 if you round, right? And 1.2533, 253 rep. So those are the answers I want. So the important piece of information is that you need to mention that dy dt can't be 0. You have to know that that's part of this issue. So just to be clear, that's part of this problem. I know that can be a frustrating part of this problem. I personally found the most frustrating part that when you want to set something in parametric equal to 0, it's easier to do it in function mode. There you have it. So, okay, part B. Write an equation for the line tangent to the path of the particle at t equals 1. So anytime I want an equation of a tangent line, I need two things. I need a point and I need a slope, right? So in part B, right, we want the equation of the tangent line at t equals 1. Well, that's going to involve two things, right? So that's going to involve, one, the point, which is going to be x of 1 comma y of 1, which right now I don't know. So that's actually, because I only know x of 0 and y of 0, which is frustrating, but it is what it is. The second thing I'm going to need is I'm going to need the slope, right? Well, that is going to be dy dx evaluated when t is 1, but that's the same thing as saying y prime of 1 over x prime of 1, which is really just the two values I already have evaluated at 1. So that's not awful, right? And that's one thing that your calculator actually can do, right? So the problem is that your calculator, can find both of these values, because if you hit trace, right, so if your graph and you hit trace, remember that these two values are your actual y and x on your current graph. If I hit trace and then hit 1, enter, it'll take me to those values. So now that y and that x are the values of y prime of 1 and x prime of 1. Now I can either store them in my calculator, or if I only anticipate having to use them once, I can quit out of here and do alpha y, because currently that's the y value, divided by alpha x. Notice that I have to use the x that's farther down. I can't use this button for x because I'm in parametric mode. So, sorry, this button for x only works in function mode. And I get that this is a 0.863 blah, 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 blah. So I get this is a 0.863447165, but I'm probably going to end up keeping only the first couple digits. We'll talk about that in a sec. But then I also have to find, so this is the harder part in this problem, right? So I'm going to end up keeping this piece for the slope, right? That's fine. What's slightly harder is that you have to use the first fundamental theorem of calculus to find x of 1 and and y of 1. So let's talk about this point. The first fundamental theorem of calculus says that if I integrate x prime of t from 0 to 1, I get x of 1, which is the thing I want, minus x of 0. So essentially, if I add the x of 0 over, x of 0, plus the integral from 0 to 1 of this x prime of t dt is going to give me x of 1. And I'm going to be able to type that in and get a number. And the same thing is going to be true with y of 0 plus the integral from 0 to 1 of y prime of t with respect to t. That'll give me y of 1, right? So, so what's going to happen is I can type both of these in my calculator by doing whatever this number is, right? In this case, x of 0 was a negative 2. Y of 0 was a 3, right? And then I can use math 9 to integrate. So if I do negative 2 plus math 9, right, I want to integrate in parametric my x1t, comma, with respect to t from 0 to 1, right? I type that in and I get a number. I get 9.314695096, but I'm only going to end up keeping up to here, right? And then I'm going to hit second enter and do the same thing, right? So second enter, but I'm going to change the -2 to a 3, and I'm going to change the x1t. Second insert, I didn't mean to delete that. I go to parametric, I pick y1t, and then I hit enter, and that's going to integrate for me, and I'm going to get that this is a 4.6205366603, but again, I'm only going to keep up to here, and I can either round or truncate. So what's going to happen is that when I write the equation for my tangent line, it's going to be y minus the y value, which is this 4.620 or 1, right, equals m, which is 9.3, oh, I'm sorry, wrong one, which is 0.863, right, x minus the x value, which is the 9.31, either 4 or 5. Now, they didn't ask you to solve for y. If you wanted to solve for y, I would suggest just adding the negative 4.620 over, right? But that's the equation of your tangent line, right? Or y equals 0.863 in parentheses x minus the 9.314 or 5, right? And then outside of that, I'd add the 4.620, or it could be a 1, right? So either of those are fine, but that's the equation of your tangent line. Now, in this particular problem, this was the big money part of the problem. It was worth 4 points, and the rest of the problem pieces were much smaller. So because this required so much, because the point was so hard to find this time, this is definitely the big part of the problem. Part C. Find the speed of the particle at 1. So that one's not hard, right? That's going to be a single point probably on any AP because there's not much to that. So part C is mostly about knowing the speed formula, which is that it's the square root of x prime of 1 quantity squared plus y prime of 1 quantity squared, right? Now, interestingly enough, those were just stored in my calculator as x and y, right? And if you're not sure if they are, like, if you're not sure if that's still stored as x and y, you could go back and you could hit trace and you could put t as 1. And then right now, stored as x and y in my calculator are x prime of 1 and y prime of 1. So I could just type into my calculator, if I quit out, square root of alpha x, and again I have to use the x that's at the bottom because I can't use the one on the independent variable button, squared plus alpha y squared. I could type that in because that x and y are stored correctly, and I'm going to get that my answer is approximately a 4.105. And that's all they want for that. They need you to set it up and give the answer. There you go, right? Part D, find the acceleration vector at the particle at t is 1. So this is another one where your calculator will do most of the work. You just have to understand, like, you need to communicate that you know the acceleration vector is going to look like this, right? You need to communicate that you know it's x double prime of 1 and y double prime of 1, and then you're allowed to let your calculator do the work. So I'm going to show you how you let your calculator do the work. You can't second calc intersect or second calc 0 in parametric, but you can do some cool stuff. Ready? You can second calc dy dt and dx dt. If you want, you already have x prime, right? That's what we put in as our x1t. So if I want the derivative of x prime at 1, I would do dx dt, and then I'd put 1 in as the time. And that's going to give me a negative 28.425. Now, you could also have done that doing a math 8, which is n derived, and then x1t at t, or with respect to t at 1, and that's fine. But again, this is one of the things you can do in parametric, that you can't do everything that you're used to doing, but you can do this. And I do the same thing. I find dy, so I find dy dt at the same spot, second calc, that would be 3, and I want it at 1, and they're going to give me dy dt is a 2.161. And that's my answer, and that's it, right? Now, again, the other way to do that, if I quit out, is to math 8, right? And then vars, I could do parametric, pick x1 with respect to t at 1, and I assure you that's going to give me the same negative 28 answer that I had, and I could do the same thing with y1t if I preferred here. So, but it is a nice faster option on the calculator if you can do it from the graph.